Hi everyone and welcome. Today we're going to be going through examples of scales from 3.1 through 3.4 to review for our quiz that's coming up. So first let's start off with definition of a polynomial. So in this case here, which of the following is a polynomial? Remember our three rules. No negative exponents, not allowed. Additionally, we can't have any variables on the denominator, also not allowed. And then finally, can't have any roots of variables. Again, all of those things are not allowed. So we see a couple of rules broken for number one. We know that this is not a polynomial. So let's do the same thing for the second one. If it is, justify. If it's not, tell us which one of these three rules it broke. Next, we're going to take a look through at combining like terms here with different polynomials. So first, let's identify like terms. We have our constants. We have our first degree term. We have our second degree term, which actually has no match here. We have our third degree term, also no match. We have our fourth degree terms, those do have a match. We have our fifth degree term with no match. And finally, we have our sixth degree term. So basically, we are just linking up all of these things that have things in common. So 8x to the sixth, nothing in common, so we leave it there. Plus, because we are adding on that other side, 4x to the fifth power. Again, no other red in common. We have some yellows in common, so 4 minus 1 gives us 3x to the fourth. Again, combining our yellows. No greens in common. No blues in common. We're on that brown highlight, so 2x and 7x, that gets us 9x. And then finally, we have our purples in common, our constant, so -7 minus 8 to get us -15. So that's our final answer. Combining this out, we'll see it's an order of degree, so from 6th degree all the way down to constant, and all of our like terms have been combined. We do the same thing for number 3. The only difference is we're subtracting each of these, so make sure you distribute that -1 into each of these three terms. Once you do that, again, find those like terms, put them together correctly, just like we did above. And again, annotation, color coding, any of those things, if that helps you to identify what is in common, definitely do those things. Next, some multiplication and then division. So multiplication, I feel confident in our ability here, so not too much to say about this, just make sure our box matches our terms. So 3 terms on top, 2 terms on the side, and now let's multiply the insides of this box. Secondly, for number 5, a bit of a trick question here. When we are dividing, we have to go in order. So we have a third degree, first degree, and then a constant. So we need to make sure that we rewrite this first as 4x cubed plus 0x squared minus 1x plus 2. So again, going in order of third, second, first to 0 degree, divided by x minus 2. And let's set up this synthetic division. Inside of our box, we put the opposite of what we have circled here. So instead of -2, we put +2. Then otherwise, we are bringing our numbers directly down. So our 4, our 0, our -1, and our +2. All of those go directly down. And then now we need to follow our synthetic division steps. So bring down that first number, multiply it by what's in the box. Combine those two terms, and again, multiply it by what's in the box. Combine those two terms, and again, multiply it by what's in our box here. Finally, combine those terms to finish. All right, so a quick look here. Always good to check that we didn't make any mistakes. Looks like we are in good shape for this question. So our final thing we need to do is identify our remainder, our 0 degree, our first degree, and our second degree in order. And again, we'd keep going up if we had more terms, so our remainder is always over what we divide by. In this case, again, circling it for a second time, we divide by x minus 2. Our 0 degree is our constant. Our first degree is x to the first power. Our second degree is x to the second power. And we have our synthetic division answer for number 5. So again, check your work for this one. Make sure you have all these steps out. Maybe look for some additional practice questions if we need them. Seagate 12 is always a good resource for things like that. We'll be in good shape. Finally, going to look at some factoring. So again, a couple of different types of factoring that we're going to see here, and we'll go over, we'll say, maybe 2 or 3 examples of these, of things that have come up commonly. So our first one, two terms like this, we want to factor out all the things that we can. So we can factor out 8 into 8, 4, 2, and 1. X cubed, we have 3 x's. Y, there is a single y. For negative 6x squared, y to the 5th. We can factor out 6 into 6, 3, 2, and 1. We have 2 x's, and we have 5 y's this time. So what do we have in common for all of these things that match up? So things that we have in common here that we can highlight. We have a 2. We have 2 x's in common, and we have a single y in common. So for these terms, we can take that out. So we can take out 2x squared times y. So we need to match that up to 8x to the 3rd power times y. So that's going to give us 4x minus 3y to the 4th. And to check our work, if we distribute 2x squared y in, for our first term we would have 8x to the 3rd y. For our second term we would have negative 6x squared y to the 5th. So that is our, again, least common factor there, and our full answer. All right, so that's one type of factoring. A second type of factoring directly beneath it, box method, we have our first and our last. This is a subtraction problem. We're going to break 20 down to things that when we multiply, get 20. And let's go through and see which one of these works. So we got 19, we got 1, we get 8. 8 is what we're looking for, so we're going to use as our edges 10 and 2. But again, it's a subtraction problem, so we need one of these to be negative. Well, if we look, we have negative 8. So let's try with negative 10. So here we get negative 10x, positive 2x, combine those, and we get negative 8 as our center term, which is exactly what we're looking for. So our final factored form, x minus 10, x plus 2. All right, a last one to point out. Our formula here, we have the sum of cubes. So again, we're going to be using that a plus b, and then times a squared minus ab plus b squared. And we have to identify, okay, a is x, and then b is the cube root of 64. So let's just make sure we're getting this one 100% right. We're looking at 4 for b, and we can plug that in for those values, make sure we're squaring them where we should square them, and we'll be in good shape there. So again, break it down, plug it into the formula if we have the sum or difference of cubes, a formula we're definitely going to need access to, but good thing assessments are open notes. All right, everybody, so as always, any questions, let me know.